Hello and welcome to this Any Excuse for a Chemistry Experiment video. Today we're going to be looking at another required practical. This time it's going to be paper chromatography, looking to separate samples of different coloured dyes. We've got two things that we need to consider for this experiment. The first one is our mobile phase. Now the mobile phase is what it sounds like. It is the phase that moves, and in our case the mobile phase is going to be our solvent, which is water, and I've got that in a beaker here. The second thing we need to consider is our stationary phase, and the stationary phase is the bit that doesn't move in our experiment. This happens to be our chromatography paper. When we apply our samples onto our chromatogram, two things are needing to happen. First of all, we're going to need to dissolve our sample into our solvent. This is key. The more it dissolves, the higher up the chromatogram it'll go. If it doesn't dissolve very well, it will remain lower down on our chromatography paper. We want to have a good blend between the two. The second thing is the interaction between the sample that we're trying to analyse and the chromatography paper. The more attracted to the paper it is, the lower down it will stay, and the more repellent it is from the paper, the higher up our chromatography paper it will travel. Now, in chromatography, we have to consider another two things. First one is, how far does our sample travel up the chromatography paper? And the second thing is, how far does our solvent travel up the chromatography paper? Now, the only way we're going to find that out is by doing our experiment. So let's have a look at how that's done. Job number one. We need to put our line for our samples to start on. We need to make this one of our control variables. So we're going to measure up from the base of our paper about 1.5 to 2 centimetres, and we're going to draw our line in pencil. Now I'm sure you all know why we use pencil, but pencil is made out of graphite, and graphite does not dissolve in water, so it won't affect our results. Job number two, we need to mark on there the samples that we're going to do. So we'll evenly space them out. So I'll put a little cross where I want my samples. Now the samples that we're going to use, we're going to have yellow. So I'm going to mark that with a Y for yellow. We're going to have a purple colour there. And we're going to have a red. So I'll put an R underneath there. We're also going to have a sample that we don't know. This sample is our unknown. Now we can either use a capital U, or I like to use an X. Next, we need to use capillary tubes. Now capillary tubes are going to take up a small sample of our colour so that we can place it onto our line. We've got to make sure we have a small dot that is concentrated. So what I'm going to do, if I stop at that, I'm going to have a small dot there, but I'm going to double up the concentration. Got a new capillary tube, do the same with my purple sample. Got to make sure I don't contaminate my capillary tubes because I don't want the colours mixing. There we go. And then finally, for the colours that I know about, I'm going to take my red colour. And I'm going to spot that. I'm going to go back to my yellow. I'm going to increase that concentration. Go back to my purple. Go back to my purple. Increase the concentration there. Back to my red. Increase my concentration there. So that's my coloured samples done. I'm going to do the same again now with my unknown colour. Now in the exam they might ask you to do different dyes, they might ask you to do different inks, they might ask you to do colours, food colourings. There we go. There's our samples ready to go. So now we've set up our chromatogram. We've got our high concentration, small samples of each of our colours. We're now going to put them into our beaker so that the solvent is touching the bottom of the paper but does not touch the bottoms of our samples. Here we go. I'm going to place a lid on to make sure that the conditions inside our beaker remain constant. As we can see, the solvent has made it all the way up to this point already. And we can see that the colours have dissolved in the solvent and have come up as well. But what they're not is right at the top of the solvent front, which means that they're beginning to separate out. Two things that we need to know: the distance our sample travels and the distance our solvent travels. We'll leave it to go for a little bit more, probably 3/4 of the chromatogram before we'll take it out. So here we go. Our solvent front has made it up, 3/4 up of our paper. So what we'll do is we'll take it out now. Now, lid off, paper out. And we've got to dry that paper now. But before we do, we know that water is colourless, and when it dries, we're not going to see where it is. So we're going to get a pencil and we're going to mark on there where our solvent front reached. There we go. There is our chromatogram. So now let's have a look at the scientific principles. To start off with, we'll have to look at a thing called the retention factor. Now, the retention factor is a number that is given to a sample when it looks at the ratio between how far it travels versus how far the solvent travelled. So the equation is RF is equal to distance moved by our sample divided by the distance moved by the solvent. In this case, let's have a look at our yellow sample. You can see that our yellow sample has moved 4.5 centimetres. The solvent, our mobile phase, has moved 10 centimetres. So the RF value is going to be RF is equal to 4.5 divided by 10. An RF value of 0.45. Now, when you do this calculation with any of your samples, you must make sure that your number will always be less than 1. If it's not less than 1, you've gone wrong somewhere. You're going to have to go back and retry. What other conclusions can we gather from a chromatogram similar to this one? Well, the first thing is that we can see that our unknown sample X has got 2 different colours in it. We also can see that our sample X contains the blue colour because the RF value is the same. Not because they're the same colour, the RF value is the same. And the third thing that we can tell is that there is an unknown colour in our sample. Let's have a look at some exam style questions. I've seen 3 things that might come up. The first one is how to carry out the experiment, the classic write out the method. Second is recalling facts about chromatography. And the third thing is interpreting chromatography results that might be given to you in the exam. So let's have a look at our method. Number 1, we drew that line, didn't we? About 1.5 to 2 centimetres up from the base in pencil. Next, using capillary tubes, we're going to place our sample onto the line. Remember, we're going to have some samples that we know about, some colours that we know about, and we're going to have one colour that we don't know about. Next, we need to pour a small amount of water, our solvent, into the bottom of our beaker. Remember, the level needs to be below the dot on our sample. Next, we're going to put our chromatogram into our beaker. We're going to place a lid on the top and we're going to wait until the mobile phase reaches about 3/4 of the way up our chromatogram paper. Once it's got there, we're going to remove it, mark our solvent line with a bit of pencil and leave it to dry. and then we can use our rulers to measure the samples and the solvent front. There we go. That's the method for chromatography. Thank you for viewing this Any Excuse for a Chemistry Experiment video on chromatography and the separation of our different colours. If you liked it, please click the thumbs up button. Subscribe to Any Excuse for a Chemistry Experiment. Check out all of the required practicals in this playlist. Thank you and goodbye.